I see 9 people. Yes, and then it's 7 o'clock, time to start. Yes. So already thanks for joining, I would say, to speakers and attendees, of course. I'm Sebastian Eggermont. I'm located in Belgium, in Brussels. I'm actually in the day-to-day life, I'm working in the chemical industry. But today I'm here, of course, as a hobbyist, like most of us, I guess, to present this meeting of Commodore users. I insist again on the users, so because you have so much groups of collectors here and there. Here in these meetings, of course, we are inviting people who are really doing things with Commodore computers, not only Commodore, but also Amiga, of course, and then whatever type of new devices it can be, like the C64, the VIC-20. I've seen this week something really nice, which is called the Mini PET series. If you haven't seen that, I encourage you to Google for that. It's a really nice little machine. The agenda today, so it will be a bit distributed between Commodore 64, a bit of basic project that was written, a program that was written basic for the C64 actually. Some Amiga related topics with the Waffle device. Also PET and CBM-II with a VGA interface. We have later on Wilfried, hopefully, that will join with an assembler macro library for VIC-20, C64, C128. Then again, some Amiga and AMOS programming with a new editor, and then we have a discussion about Zappedto. Apart from that, I need to inform you that, of course, this conference is being streamed live currently on Facebook, but I will also record each of the talks, so that later on we can store them and share them via our not Facebook but YouTube channel, right? So you know that all the talks from the previous meeting, the March meeting, are also available on the YouTube channel, and the whole recording is still available as well from our Facebook page. Okay. So that's more or less it for an intro. At the end of after the last speaker today, I will also let you know when is the next meeting, because we have already foreseen and scheduled the date later on this year for the next meeting. That time it will start again like in March in the morning, so it will start like something like 11 o'clock, because then we will have at least one speaker coming from East Asia, a European fellow that is living over there and has a nice project to share with us. Then, of course, to make it quite convenient for him, then we will start. Next time it will be the start in the morning. I think we are more or less to the 7.5. Not really. I've been fast enough. I don't know, Greg, if you want to start already, if you want to wait a couple of minutes, maybe we can start immediately with you. That will allow more time for questions and answers later on. Also, just all know, be aware that this is, of course, a hobbyist meeting. We are not that strict on the time that is allowed. If someone has a few questions after a talk, we should, of course, allow some time for Q&A. Greg, the floor is yours with C64 OS.
Okay, so I'm just going to share my screen. Everybody can see my screen?
I can see your screen, yes.
Okay, so hi everyone. My name is Greg Naçu and I live in Canada. I have a long history of love for both the C64 and for operating systems. In late 2016, I decided to get back into my C64 after an 8-year hiatus, and I started learning to program in 6502. I had ideas for an OS, and I decided to call it C64 OS. I set up a website, C64OS.com, and I've been blogging about my progress for a few years. I'm quite far along, and I was invited to give you all a demonstration, so here we are. So we'll start by booting up. This instance of C64 OS is installed on an SD2IEC. It runs on a stock C64, but requires a boot storage device with native support for subdirectories. So this includes the CMD devices, IDE64, and SD2IEC. So we're taken first to the app launcher. The app launcher is a desktop-like environment with configurable background image and customizable aliases. These are links to other applications, C64 OS utilities, and also to regular C64 programs. So the app launcher supports 5 configurable desktops and up to 32 aliases per desktop. Aliases can be rearranged simply by dragging them like this. And also you can drag selection boxes around groups of aliases. So you can drag a bunch of them at the same time. And you can also change the colors of aliases by using the standard color picker. So we can select some aliases, pick a new color, like so. So I'm gonna just reload state the way they were before. So the menu bar that runs along the top of the screen here and the status bar that runs along the bottom of the screen are common to all applications. Menus are really fast. They're hierarchical like this, and they support customizable keyboard shortcuts. The status bar has different modes that you can switch through with a click. So this current mode is showing the application's custom content. So in this application, as we make selections, it's showing you how many aliases are selected, and it can show other custom messages. With a click, this is now showing us the latest drive status. So device 12 is the SD2IEC, and this is its latest drive status. On the other end of the status bar, we have a display of the currently available memory. So there's 20 kilobytes of memory available right now. The next mode of the status bar shows the currently open or selected file. So if I click on these files, this is these aliases, this is showing the path in the file system of where that alias is located. In the menu bar on the far left end, we have a utilities menu. So these main menus here are, they change per application, but the contents of the utilities menu stays the same from application to application. So I will choose the About This App utility. So here we have a utility which we can move about. So this shows us the version number, the copyright information, and the application icon for whatever application is currently running. So this is showing us the app launchers. Next, I'll open the settings utility. So the settings utility basically gives you access to other utilities that are all geared towards customizing the settings of the operating system. First of all, I'll say a couple things about utilities generally. When a utility is open, the application in the background is still totally active. So these menus are active. We can click on content, and basically everything that you can do in the app, you can do in the app while a utility is open. Additionally, utilities support window shade. So if you hold the control key and click on the title bar, you can collapse a utility into its title bar just so that you can conveniently see what's going on behind it. So I'll use the settings utility to open the themes utility. The themes utility lets you change the color theme or to customize your own color theme. So with this button down here, we can toggle through the color themes. There are 2 built-in themes, daylight and midnight. So midnight's kind of a cool dark theme. And then you have this custom theme. So you can click on any of these user interface elements to select it, and then you can click on this button here to cycle through changing the color of oops, sorry. That was the background color. So you can customize all of the various user interface elements. So I'll just go back to the daylight theme. Now, in the app launcher, I'm going to switch desktops to, say, desktop 2. Okay, so here we can see that the background image is completely different. There's a different arrangement of aliases, different colors, just to show you that you can really like customize your desktops to suit your needs. Now we'll switch to, say, desktop 5. So here again, you can see a totally different background image, different color, different layout of aliases, and so on. Now, of course, the app launcher is meant to let you launch into apps. So I'm going to double click on the gallery app. So when an app is launched, you see this standard splash screen, that standard splash screen that you saw. So every time you switch an app, you see like that splash screen. So now this is a totally new app, new user interface. These menus here, these main menus are all different, but the contents of the utilities menu is still the same. So I'm going to now click on, say, this wallpapers gallery to open it. So we got some metadata filled in here. But you also notice that once I've opened this gallery, there's this new status icon here, a little up arrow in the status bar. So that icon indicates that you can drag the status bar. So we can drag the status bar up to activate a split screen. So split screen is a feature that's built into the operating system that applications can tap into. And both halves of the screen are active, so we can interact with the menus and the application buttons in the top. And we can also interact with the content at the bottom. So I'm going to click down here to, say, switch the image. Now, we can also use a keyboard shortcut to switch into full screen graphics mode. And then I'll click to cycle to the next image. So we can switch back to split screen. Let me show another image. Switch back to split screen. So next, I'm going to choose options go home. That's going to take me back to the app launcher. See that splash screen again. Now, one of the things that I wanted to point out about the returning to the app launcher is that I'm taken back to the desktop that I left from, because apps remember their state when you leave them. So from the app launcher now, I could launch into, say, another app. But what I'm going to do is I'm going to switch into the file manager. So file manager and the app launcher are kind of like built-in apps. And so there are quick ways to switch between them. So from the Go menu, we can choose File Manager, or it has a keyboard shortcut. So File Manager showcases an advanced user interface that is built from C64 OS's object-oriented toolkit. First, we have this vertical split. So we can click anywhere on this bar and drag it left and right to resize the halves of the screen. And you can see that the user interface is responding in real time to the new size. So I have, for example, this horizontal scroll bar to scroll the content horizontally. And then we also have these tabs up here that have contracted to better fit the space that's available. So I'll just make this a little wider. Yeah, so there are these 4 tabs allowing you to be in a different place, a different device, partition, and directory, 4 different places at the same time. So then you have the actual list of files. So the list of files is displayed in a table which has resizable and sortable column headers. So I can just click on the column header like this to resize a column. I can resize this column. And you can click on these column headers to sort by the various criteria, sort alphabetically by file name, ascending and descending. And to switch into to change a directory, you can just double click on a directory. So here we are in a new directory. Now you also see this path bar up here, and down here you have this this kind of info bar. So those can be turned on and off. So we could say view path bar and view info bar, and you see the UI adapts to fill the available space. Those also have keyboard shortcuts, so I can bring those back with some keyboard shortcuts. Now the path bar, not only does it show you where you are, but you can also interact with it to jump back to places in the path. So I'll go back up a directory. This here that we're looking at is actually the system directory, so you can kind of see a bit of the organization. For example, the desktop, drivers, kernel, library, settings, etc. And you can make selections. So we can select, we can make range selections like this. We can make individual selections. And I'm making those selections by clicking on things while holding the Shift key and the Commodore key. So I wanted to show you just a little example of sort of a file management task. So what I'm going to do is I'm going to use the file manager to make a backup of the app launcher's desktop directories. So I will start by going to tab 3. And then I'm going to navigate the file system. So I'll click on my SD2IC device and I see a list of partitions, and I'll click on partition. I have a backups folder. So I'll go into that, and I have a desktop directory, so I'll go into that. Now what I'll do is I'll go back to tab 2, and I'll go into the desktop directory. Now I'll use multiple selections to select each of these desktop directories. And now I'll go File, Copy to tab 3. So that opens this copy utility. So you could cancel the copy by closing the utility, or you can confirm by clicking Start. So I'll hit Start. And so now this is recursively copying all of the selected directories and all of their contents to wherever tab 3 is. You see this cool little icon of a file moving between the folders. You get a count of how many items have been copied so far. And if this was copying between devices, it will use the REU to accelerate disk file copying. Okay, so that's done. So now when we go back to tab 3, we can see that indeed each of those directories has been copied, and we have a backup of the desktop aliases. So that is just kind of an example of some file management tasks that you can do with the C64 OS file manager. Now, I don't have a lot of time, so I thought that I would just give an example of some useful utilities that are in C64 OS. So if you double click, you can do this at any time, you can double click the available memory in the status bar, and you get this memory utility. So the memory utility shows a real-time visual display of how memory in the C64 is currently allocated. This also shows that a 2 megabyte REU has been detected. We have 19 kilobytes of memory have been used by this application, and 11 kilobytes are available. You can also, at any time, double-click the time in the menu bar. And that opens this calendar. It's called the Today utility. It's kind of a calendar program. So it's kind of a work in progress, but you can cycle through the months and years. You can click on individual dates. And the idea will be that I'll let you add notes to each individual date. And lastly, from the utilities menu, I'll open, say, the calculator. So calculator, just as you would imagine, we can do some calculations here. And we can open this above whatever application is going on below. And another kind of cool thing about this calculator is that it's for all of its floating point math, it's actually using the basic ROM in the computer. So that's pretty much the demo that I wanted to give. And I wanted to leave some time for questions. So you can find out more about all this at C64OS.com, where I am very busy right now working on the user's guide. And then after that, I'm going to be working on a programmer's guide to document all the APIs for third-party developers. And yeah, so we can just, do you want me to open the floor for questions?
Yeah, maybe first question for me. Are you developing that all but by yourself alone?
Yes, so far, yeah, everything's been developed by me. I've got some beta testers. I've been running a beta program for about a year, maybe a little over a year. So I've got some people who are helping me test.
That's good. I see some comments here. Excellent work. Are there any questions for Greg?
Yeah, I have a question. I would like to know how you manage the back and forth from application. Where I mean, the memory is not too large to store everything, stack, and other stuff like that. You know, from jumping to an application to another. So if you change it to desktop, from desktop 2, for example, to desktop 1, when you leave the desktop 1 to desktop 2, where do you store the information, the stack, the RAM area for the previous application, so you can go back in the same memory layout you are living and back and forth, you know?
Yeah, so C64 OS is not properly multitasking, because in my opinion, there's just not enough memory to do like full proper memory multitasking, and really give enough memory left over for applications to do interesting things. So in the case of the desktops, it saves the current state of the desktop to the storage device when you leave a desktop, and it loads in the state of the next desktop when you switch. The file manager is actually a little bit more advanced than that. When you load in directories into tabs, the contents of the directories remain loaded into memory only as long as there's enough memory. So it remembers like the order of which tabs you accessed. And if it runs in a memory when it's trying to load in a directory, it'll automatically deallocate the last, like the tab that you've used least frequently. And then if you switch back to a tab, it will, it just automatically reloads that content in. So it does a lot of writing state out to disk so that when you come back to it, it loads the state back in from disk, and it feels like you've picked up right where you left off.
So if I may follow up with a question to that. So how is memory management then done? Is this all loaded to fixed addresses, or are you doing some kind of relocating with all the swapping out and back in?
Yeah, that's a great question. Yeah, there's a combination of some things are loaded to fixed memory addresses, some are not. So applications load to a fixed address. Utilities load to a fixed address way up high in memory. But there is a dynamic memory manager for everything else. So drivers relocate, so they can be dynamically loaded and unloaded, and they get relocated to wherever there's space. Libraries, there's a shared library system that is relocated. Toolkit widget classes, there's a core set that are built in, but then you can also make additional ones that get loaded in that only get used for certain applications. They get relocated. Yeah, I don't know if that answers your question, but it's kind of a—
Yeah, thank you. Wow. Are you using your own relocatable format, or?
Yeah, actually, I wrote a blog post about how I'm doing the relocation, but yeah,
I read it, but I don't remember.
Yeah, I came up with my own mechanism for relocating 6502 code. It's limited. It's limited to up to about 2 kilobytes. So you can't relocate like a 30K chunk of memory using my technique, but it's very, very lightweight and doesn't require a special assembler. So I like it.
I see a question from Michal. Is there any networking support like TCP/IP, etc.?
Yeah, so there isn't networking yet, but I have many plans, and So support for things like the REU and support for networking are in progress.
Okay. Then I see, when can we expect to test it? So you said you have
that's
some
the
beta available, but when do you release something?
Everybody wants to know that. And yeah, I apologize if my development is a bit slow because, but actually I do all my development on a Commodore itself. So that's kind of bonus points for me. But it does make development a little bit slow. I just, I want to release as soon as I think that it's useful. I don't want to just wait forever, but I don't want to release it when it's not useful, but it's pretty close because at this point there's a lot of things that I can do with it that are already very useful for me. But you can also see that there are just things that are not done, like this favorites section here is I just haven't finished that part yet. So
so you're developing this, you said, on a Commodore, but you need then a RAM expansion unit or something, right?
I do the development on a Commodore 128, and I do use an REU for development. And the system will use an REU if you have one, but you don't need an REU to actually run C64 OS.
Okay, that's good.
Yeah.
I don't know if there are other questions. I don't think so. Otherwise, if questions arise, you can of course always ask them in the. Yes, please. Yes, go for it.
So I suppose you're not using the kernel at all. So your system can run without any kind of ROM.
It can run with any kind of ROM. Actually, it does use the kernel.
For what?
Yes. C64 OS actually uses the C64 kernel. And it even uses the basic ROM occasionally for certain routines that are in the basic ROM, like the way the calculator patches the basic ROM in to do that. So yeah, it uses the kernel. It uses the real kernel. That's actually a good question because I don't have custom disk access routines. So a speed loader is like highly recommended. I personally recommend Jiffy DOS, which is like a full kernel replacement and makes the disk access much faster. But yeah, I'm using the kernel ROM.
Good. Thank you. I will stop recording this talk now. You want to stop cloud recording? Yes. And in the meantime, then Magnus, you can start maybe sharing your screen. Thanks a lot, Greg. I don't know if you stay around, then maybe if there are other questions coming in the chat, maybe you can answer them in the chat as well.
Yeah, thanks. I'm going to stick around. Thank you.
Thanks for that. Then we have Magnus sharing, I guess.
Let's see. Can you see something now?
Yeah, we can see something Swedish, so it should be you.
Yeah, it must be me. But can you see a Commodore 64 on the screen?
The VIC-64. Commodore
VIC-64. That's what we call it in Sweden.
Anwendermanual.
So now you see me?
Sorry?
Are you ready for me?
Yes, absolutely. Please go.
Yes, okay. My name is Magnus and I live in Sweden. And I bought my first, I really didn't buy it. I got it for Christmas present in 1983 when I was 12 years old. And I started to play games and program on it. And later on, in about 84, 85, most kids in my neighborhood have got one C64, but they almost only use it for games. But I tried to program on it. I wrote some simple games, like some kind of Hyper Olympic was my the best thing I ever done, I think. A simple one in just BASIC only. And later on, when I was 16 years old in 1987, I sold my VIC-64 and got an Amiga. And let's see here. Early this year, I found, let's see, there we got it. This one at the Media Mark store, the new 64, and it makes me go back to my childhood again. And I was scared of how my memory recall all the codes that I haven't used for 34 years. And I did some simple games on it. And the game I'm gonna demo for you now is called Tetris. You know that one. The first time I heard about Tetris was in 1989, so that was long after I sold my VIC-64, so I never had the opportunity to try to program it on the C64. But now when I got my new, the 64, I tried to do it, and I think I did a simple version of it with no cosmetic, but it works, and it's in basic and basic only, and it's made on this C64. Let's see if I can get back to zoom again. Am I on?
You're still there, yes, but we can
still there.
screen. Yes, yes, yes.
Let's see if you can see my. Now I'm gonna try to start the application here. It's so. I did the best I could with the music. I will explain later how I did it.
I see everyone reaching out to the volume button.
Okay, is it too loud for you?
It is quite loud indeed. Yes, yes.
It's quite loud. Oh, okay. I tried to turn it down somehow. It should be somewhere.
Isn't it there after the two? So you have one time, two time, and then you have this kind of square, and yeah.
Oh, now I see it. Now I see it. Oh, 60. That's loud. Now, oh, that's better.
That should be
so it's worked like this. Now this is the PC version where you can use your keys. On the C64, you can use the joystick, and that's great. That sound was better, wasn't it?
Indeed, yes.
Yeah. So you rotate, and then these are sprites falling down, and when they reach the bottom, it converts to normally. See if I can get some point. And I use the A key to go left and L to go right. And then I use the space, I can speed it down a bit. I think I kept going until I get at least 1 point. I hope I can make it. I will make it on the next one. So now I will get a single row. I hope it's. Yeah, it gives me 1 point. That was what I was looking for. And how did I do this? I break it here. So this is the list of the full game. And all these are things I remember from the 80s. Some pokes I have to goggle up because I didn't remember the sound pokes or some other things. And the sprites you see on the screen, they are large ones. So these are only 2 dots for each square. But if you take the program from the beginning, it starts this is just moving the memory a bit, so it's 2000 and down. That should be the start screen, and then we go to, this is where I did the music. So I put on a play string and get the tunes for Tetris to Kalinka, which I found somewhere on the internet, and put it in this size, and then this is the delay of each tune. And this is the second voice of it. And then this one, read the tune, see, and put the values for that tune, and then play it, and so on and so on. Then it jump back to the program and sets up the screen. The first thing it does is print. This is very simple done, so it's not cosmetic at all. This is just making a box where the Tetris are going to fall in. So it's just pokes and prints almost. Then we go further down here. This is the game loop. It's not quite long. This is asking for, so this is left and right and so on. And this is just a reminder where we are on the screen. So you can see there's nothing standing in our way, because if there is, we won't be able to move left or right or whatever. Oops. And so this is the game loop. It's not so long at all, but this part is where the figures are made in the memory, because this is figure 1, for example. Then it's all made of 4.4 buttons. So it's this dot 1 is light on, dot 2 is light on, and so on. And this make the figures as we call them, like the green one you see on the screen there. And when I made the sprites, I didn't have a sprite editor or something. I just made them from this data. So it's, this means 2 points, 1 point, no points, and so on. So that's just writing the sprites. See something more interesting. And this is yes. Oops. Do that one again. Okay.
But so you're using maximum 2 sprites, right? One that is just announcing what is the next block, and then you have the one that is actually moving, and then when it reaches the end of the bottom of the screen, then it turns into PET or something, right?
Yeah, that's just what I say. So it's 2 sprites on, and you still see the sprites on the screen. So when that one, the blue one, comes down, it converts to normal charities. And this is set because TT is the random sprite. If the random is set from 1 to 7, if it's 1, it goes to 500, and it writes prepare the computer for the green sprite, for example, and put it on the screen. And after that, it chooses the next one. So when that one it chooses a new one and show it in the window beside. So you have to listen to this song again, but I made a way to fasten it up a bit. So when it reaches the button now, there, it's charities again. And the hardest part in this game, I think it was when you got some points and it's gonna delete one row for you, is what to move all the other rows down 1 or 2 or 3 or 4 blocks without taking 10 minutes because it's only basic. But I did that. I can show you. I think it's easier if I show it here. So if you do like this, put it in with
So as you're loading that, maybe we can shoot already some questions. I had one. So you mentioned you didn't use any sprite editor. So even for the coding, you didn't use any editor. So you just opened the C64 and you started like in the good old days, typing your code directly at the command prompt there. Yeah,
that's right. Because I got a sprite editor which I made in February this year, because I have also done some other games, and for that I use my own sprite editor. But in this game, I didn't want to use that because I think it was more simple to more fun to write sprites in the program itself, because it's not so hard. Just 1, 2, 3, 2 dots, 1. So I did a look for that. So this is a sprite setup. So this is just the clear the sprites memory, and this is the thing is 28 different figures, because it's 7 of them, and it's 4 different side of it because they rotate. And here it's read them and it's put them like this together, and this is building the sprites up.
Okay. I'm just looking at the time. I see we are more or less reaching the limit here. So maybe we should allow for more questions if there are any.
I think I go back to.
Let me see in the text if there is any.
Am I back?
Any question? I don't see any question in the chat. But maybe you can mention where it is available then, huh? Because if it is available.
So this there is a website for my games, because I'm going to release some freeware collection later this year, and I think this will be in it too. And the link site is in your introduction on the main page, and you can just go there and you find it. And I think you even will send a link to the game itself from the site.
Yeah, indeed. So there is a link to your website, of course, on the agenda of today. That will remain, of course, on the website as well. But we have also direct link to the file that we have created this afternoon on the storage of the, let's say, the Google Drive of Commodore Users Europe. So I will post as well on the Facebook page. I will post the link there. So there are 2 versions actually. Yeah, you made one.
This is the joystick version, because
we can use the joystick, and then
this is my.
This
is my
C64. That's the C64. Yes, nice.
With the joystick, so you can play it with the joystick. But I think you need a C64, and they have to stop everywhere.
You're promoting it here. You're promoting the.
But maybe they just works with the PC as well, or if you got an original C64, I think the joystick should work. It must do.
Good. I'm just looking if there are any more questions from the chat. No, I don't think so. But maybe what we can do then is that you can remain again a few minutes in case there is someone more question. I will stop the recording now. And then I will invite next speaker, who's Gianluca, should be with us, to then start by unmuting, and then probably you
Yes,
can...
hello everyone. Do you hear me?
I can hear
Okay.
you, yes.
Okay, hello everyone again. And I'm gonna show you what can be done with an open source project and with a lot of people involved in a project like this. Everything was starting in 3 years ago. I mean, 2018, when I was running out of my floppy disk drives, and everything was, was not working in the PC world. I was looking for an Amiga drive and for Amiga disk drive, and everything was, very expensive. And the GoTech and the other solution like this are working in a real Amiga. So I don't want to put a new USB thumb drive as a disk drive because of the feeling. I would like to have old school clicking and old school Amigas like the good old days. So I was trying to put again Amiga on the road, my Amigas. I have maybe 3 or 4 of them. And as soon as I tried to turn it up, and I found the hard drive failed. So the only thing I have to do is to reinstall everything from the diskettes and floppy disk, and I have no floppy disk at all. So how can be done without floppy disk? I'm looking for a parallel port solution to write some ADF files from the PC to the floppy disk via the parallel port and so forth. And it is not working because at the moment I hadn't any PC with a parallel port. So I have to look for another solution. And Robert Smith, not the singer from The Cure, but Robert Smith, another guy from the UK, was doing the same stuff I looking for. So I was in touch with him and tried to build some kind of prototypes, because I'm working in a company and I am designing hardware, and I am designing hardware and software boards with microcontrollers. So I have access to a lot of electronic components, and I tried to use a already solution like Arduino, and it worked very good. And from my point of view, it worked like it's supposed to work. So I built up, a breadboard prototype, and it worked like a charm, but it was a prototype. So everything I moved it, every single wire went over, and so I have to re-put the wire again, and it was a mess. So I started to build up a board, an Arduino board, so it's easy to solder and to put on the drive, so it can be used very easily by anyone. So in the moment I went in contact with Federico Di Dato and with its Retrobit lab. It was a very good guy, and it forced me to improve my project. And as soon as the project was done, I went to his home and show what I've done. And he said to me, "Oh, this is a very, very, very good project. That can be sold by anyone. It can be used by any Amiga user want to transfer between the real drives, the real floppy disk to an ADF file, and vice versa." So I tried to finish the project and put the project online and as an open source. And Federico, after a while, and the other guys from the Retrobit lab were able to have a type like that. It's completely printed in 3D, and there is a real floppy disk inside. There is a Arduino custom board over here. It can be plugged in the computer, and with the software. And actually, the software runs only on Windows because of timings issues for Linux, but it can be solved very, very easily. And the software is written by Robert Smith. I adapt the software for the Arduino custom board, and until now, it was okay for reading and writing ADF files to floppy or from floppy. And in last January, Federico told me, "Hey, is possible to use this kind of hardware with an Amiga emulator on PC, like a WinUAA?" And I was in contact with Dimitris from Greece, from Amiberry board, and he gave me some indication, some hints to find out if it can be possible to communicate between the emulator and the drive. And the drive itself, I mean, the board itself, it's a serial port, like I mean, a normal COM port in Windows, and it runs at 2 megabits. So the speed is very critical, and because of the way the Arduino is writing the track on the disk. So it's very time consuming from the Arduino point of view, and so it's must be done at this speed, because in this way the rotation is synchronized with the power of the Arduino to write the correct track. So in emulator, this can be done so easily. So I mean, sometimes you have a very powerful board, very powerful PC. Sometimes you don't have. So it's very hard to fit the needs for everyone. And after I mean a lot of time, Robert and other people from the Tony Whelan WinUAA project. Robert was able to write a kind of emulator to emulate the disk insertion, and he puts the command to drive the Arduino side in the emulator, and it works pretty good. And if you want to have, I can explain this in sharing my screen and my hardware, so it can be easily understood by everyone.
Yes, please do so. Just
Okay.
know that we are reaching in terms of time.
Yes, I know. I go quick. So this is the Waffle, the Waffle drive. I put on the USB, and in the way it works, so I can start the sharing screen. Wait a minute. Okay. And so here I am. I'm looking for, I mean, the The standard way of using this hardware is using this Arduino floppy reader for Windows. And when you click it, you select the COM port, the Waffle is connected, and you have to select if you want to write or you read a disk or write a disk from an image file. And it's very user-friendly. It's easy to use. And after that, you can use your real diskette into the Amiga. Otherwise, you can use the real diskette in the emulator without using this kind of tool, because you don't have the needs to translate the real floppy to the ADF file. So it can be done with a special compiled version of the WinUEA, and it's ready for download on the Robert Smith website. And I try to show you. That's very easy. You have to start your WinUEA emulation. Choose the expansion and using disk controllers. After that, you will show your Arduino reader writer by Robert Smith, and you have to enable it. After that, I mean, there is no disk on the drive, so I'm supposing to see the hand of the Amiga kickstart. And so it starts. The drive is starting clicking. And for example, I put a game on the drive. I don't know if you hear the insertion click.
I heard that, yeah.
In the way it's running from the drive, for the real drive, I have to show you the light and the LEDs on the back is running, and it's very easy to use, and it works with non-DOS disk and DOS disk too. And you can enable with the Arduino floppy disk reader and writer, the application you saw before. You are able to copy a protected disk with the SCP, the Supercard Pro format. So you can you can do everything from the disk side of view. So from the copy protection or not copy protected. So it's ADF or SCP. So in the way, it's I mean it's a game. It's a tiny bubble. Just if I release the disk, the system will continue clicking because of like an Amiga, for real Amiga. And if I put another demo disk here, it's a demo. I put the demo inside, and after the game starts, I will reset the virtual machine, the emulator. Okay. Do you hear the sounds and everything is going is working like the real stuff? And if I wait a minute, I reset the emulation, it will start with this kind of emulation, and it reading another game, another demo. You can see over here the tracks number, and it works for real on the real tracks. So I mean, in the way I can use the real drive I have in the emulator, or I can transform the real drive I have, the real disk I have, into ADF files, or even better, if you don't have any disk for your real Amiga, you can transform from the ADF file in the emulation to the real drive. So it's the look and feel of the 80s are back. So it's a pretty long demo.
It looks really, really good. It's really nice.
The speed is the same of the real drive, so it's I mean, you cannot speed up the drive.
I see that. I guess as your this is still running, we can maybe welcome the first question. I see comments. That's fantastic. That's also what I what I feel. Maybe a question that people might have is where can I find it? You know, is this something that is available all the time from a shop? Is it? I know the answer, but it's better if you answer it.
I mean, wait a minute. I will stop the emulation because I'm hearing. Okay. So the biggest question is, we are not the professionals, so we are trying to do 3D packages, find the drives, the real drives that are hard to find right now, and even the slim drives. And for the moment, we don't have planning to build another batch, depending on how many people are looking for this project. And I mean, we did it very professionally, because we did even the cardboard box for this project, and the cables, the logos here, the quality of the plastic, everything is, I mean, it's very professional. Let's say, yeah, for us it's a hobby, but I mean, it's very well done, very well done.
So if people want to check from time to time if there is a batch that having been
yes, of course,
available, where can they? So I suppose they can look, of course, on your Facebook page, which is Retrobit Lab. Do you have also a kind of web page or website where that information is available?
I mean, in the next few days, I will put everything on GitHub for anybody. If you want to build by yourself, you have a 3D printer, or if you are able to build up a PCB and buy some components and other stuff like that, you can build by yourself. But in the future, we can have a specific website for this project, so it can easily be found on the future batches and so forth.
Perfect. Are there any other questions from the attendees?
As I understand, is it using the standard PC drive or some specific drive mechanism?
It's a standard PC drive. You can, I mean, the PC drive must be like configured like a drive A, not like drive B. And usually this can be done on the cable on the PCs, like drive A and drive B, because of the position on the cable. But in this specific way, the cable must be straight, so it cannot be switched. So the drive itself must be configured in drive A. And some drives are not configurable easily. You have to change some jumpers on the back or some solder joint on the PC board of the drive. But on the hardware side of view, you can have jumper solders on the board, so you can easily change to fit your needs for your specific drive on this Waffle board.
Okay, thank you. Any other questions remaining? If none, then I will stop recording of this talk now. Thank you, Gianluca, and then I invite our next speaker to join. I think it's you, Michal, right?
Yeah, it's me.
If I'm not wrong, let me just start as well recording them, and please, the floor is yours, Michal.
Okay, so I'm going to start sharing my screen. Okay, so today I'm going to talk about my VGA interface for the PET and CBM-II computers. So basically, it solves a problem of connecting your PET or your CBM-II to a modern monitor. There are some existing devices that can do that. It's mostly this one. It can produce a composite video screen for a PET. There are some other similar devices that you can build or even buy, but all of them share the same problems. And first of all, they are converting the existing PET video signal to either a composite or MDA or some other video standard. So it won't work when your video circuit in your PET is not working. And if you look at the PET forums on Facebook and some other places, probably the most common question that's being asked is, I have a Commodore PET, but there's no video on the internal monitor. How can I test what's wrong? And if you get no video from your PET, it can be because your monitor is broken, because your video circuit is broken, or maybe everything is broken. You don't know that. And if you are trying to connect an external monitor to this kind of PET and trying to test what's broken, if you're going to use the original video signal, it won't be much help. And the second problem with all those solutions is that they are using a composite video output. So the quality of the video you are getting is not very good. For example, if you compare the composite video that's on the left and the VGA signal that's on the right, you can see that the VGA is much easier to read. If you are spending a few hours per day with your PET trying to write some software, then the quality of the video is quite important for your eyes. So trying to solve those two problems, I wanted to make an interface that outputs the VGA signal directly without using the existing composite or other video signals, and that doesn't cost a lot of money. So that's what I came up with. It's a very smart chip from a Parallax. It's called the Propeller, and it's a very affordable chip. You can get it for $7 from their website. And it's a kind of a RISC processor for implementing I/O devices. So its assembly language has several instructions that deal directly from input and output, like, for example, wait until this the signal on this input pin has a specific value. It has specific instructions for outputting a video stream. So in a few lines of assembly code, you can actually create a video output device. And compared to FPGAs, which are commonly used for this kind of tasks, it is much cheaper. It is much easier to program because you write a software application, not some kind of hardware definition. And it's also quite easier to solder on your PCB because it comes in a through-hole packaging. So the way I'm employing it is a kind of bus sniffer for the 6502 processor. So you attach this chip to a 6502 in your PET or your CBM-II, and one of the cores is running a program that constantly listens to everything that is happening on the 6502 bus. And whenever it detects that the video memory of the PET is being written to, it updates its internal buffer. So basically, it keeps its own copy of the video screen and uses it to display the image on the screen. So it sits there on your bus. It listens to everything that's happening on the bus, and you never know that it's there. So it's completely invisible to the software that it's running on the PET. And because it mirrors the video memory and all the important registers, there are no changes necessary to whatever software is running on the PET. So you don't need to create a special editor ROM. You don't need any changes in the kernel or in the application software. It just works. It's plug and play. So once you have a copy of the video memory in the chip, you use some other cores of the chip to render it as a bitmap and display as a screen. So as you can see here, it uses 4 cores. It uses a special PET font that's larger so that it displays nicely on the VGA screen. And this is the result. So you have the PET, you have some nice game running on it, and through the VGA interface, it also connects to the big plasma TV, and everything that's on the real PET screen, it displays on the VGA display. So that's how it's working. And of course, you don't need to change the application that's running on the PET in any way. And if you watched my previous presentation about the 88 processor card for the CBM-II, the VGA display has also a special mode to interface with this card. So it acts like a MDA, a graphic card for the PC that's being emulated. There's a PC font, there's a special code dedicated to all the MDA text attributes like blinking or high intensity. And there's also an interface for the 6502 processor. So you can also display some data this way. And this is how the card looks like. The version for CBM-II is complete. So you can jump on GitHub. There are Eagle files to make the PCB. There's the firmware to be burnt into the EEPROM, so you can build your own. And the version for the older pads is in the development right now. So I have some PCBs made. I need to test them a little bit, but it's coming as well. So if you are interested, watch out my GitHub account, and in a few weeks it should also appear there. Yeah, so that's all. Thank you very much. If there are any questions, I'm happy to answer them.
Thank you, Michal. That looks really, really good. I mean, the result on the plasma screen is so much better than on the original screen. That's incredible.
Yeah, that's the point. Yeah. That's the point, that it's supposed to be much more readable.
Yeah. I don't know if there are any questions coming up.
Yeah, I have one. It's excellent work, I think. That's great stuff.
Yeah.
So obviously, I'm interested in the PET version. So
yeah, of course, a lot of people are, and that's why I set out to make it. Sure. Yeah, it's coming. Yes.
Yeah. Okay. The question is, will it plug under the CPU, or will it plug into the expansion connectors that the PET boards have? I mean, since I don't know, 4032 or something, or will it really be under the CPU so you can use it with all the PETs?
The idea that I'm working with at the moment is that it will plug under the CPU, because otherwise you would need to support only those pads with this expansion bus. Yeah. And if you plug it under the CPU, you can use it with any pad. So that's the plan. That's the version I'm working with at the moment.
Excellent. Thank you.
Thank you. I see also a question about a lag. Is there any kind of lag? No, there isn't any kind of lag. Everything is updated in real time. The only problem, and you can also say that it's a kind of lag, is that the propeller needs about 1 second to start. So you need to introduce a small delay when the PET is starting, because if the PET starts faster than this, all the writes to the video memory will be lost. So I'm putting a little bit of delay using the ready signal of the 6502, so the startup of the PET is delayed. After that, everything happens in real time.
Excellent. Maybe so apart from the fact that you will post on your GitHub account the plans to make it, you don't have any plans to build and sell these, right?
As a matter of fact, I do. Yes, I do, because a lot of people are asking for ready units. Yes, I am planning to build a batch of units and sell them, but I'm going to do that when I will when all the bugs in the original firmware are eliminated. So at the moment, what you can download from the GitHub account is perfectly usable, but there are some little details that are still missing. For example, on the CBM-II, you can use a key combination to invert the screen, and that's not implemented yet. Also, there were some questions about the German version of the CBM-II, which has its own kernel and its own character set, and that's perfectly fine for me to implement. But it turned out that I don't have any memory left in the propeller for the second character set, so I need to make some changes in the firmware to make room for the second character set. So it's all going to be done, and when the firmware reaches the version 1.0, then it will also be available for sale.
Okay, and then the info is on your GitHub, or is it also on your website?
It's not on my website yet, but it will be. So when it's available on my website for sale, I of course also update the link on the GitHub.
Perfect. Thank you very much, Michal. We are completely out of schedule, so I don't know if there are more questions, but maybe if there are more questions, please post this in the chat so that we can start maybe with the next speaker. Thanks again, Michal. I will start the recording now, and I think our next speaker then is it Wilfried? I guess so. Is he already?
According to the list, yes. Hello.
Yes, hello. Perfect. Let me just start also then recording this session. And please, Wilfried, the floor is yours.
Okay. Hello, everyone. I hope you can see my presentation at the moment.
I can see your screen indeed. Yes, yes. LAMAlib.
Great. So yes, it's about an assembler macro library, and it's basically macros and a library, which can be currently used for the VIC-20, C64, and C128. And it was made as a lightweight assembler macro library. So it's something that you can use in addition when you're doing assembly coding. So it's not necessary that you use it all the time, and you can also do all your normal coding routine and probably just use a few functions. If you just want to use a random function or something, it should not produce any overhead. If you don't use functions, they don't add to it. Currently, it's aimed to these 3 machines. This has mainly to do with my background. So I never owned a C16 or +4, unfortunately not also a PET, but given that that they're also based on the 6502 and that CC65 supports them, there shouldn't be any problem to extend it, and it's on my to-do list. And as I already said, it's a little bit more than a macro package because it also contains a function library. And yeah, basically macros for 16-bit operations, macros for structured programming. This is something you don't see often with assembler macros for being able to do structured programming. Some useful library routines that can save you some time. The support for the 3 machines is basically functions that adjust to the address layout of the target machine. And currently I'm also working on a high-res GFX part, which is not yet done. Also, this will require a lot of adjustment to the different architectures other than the normal functions. My motivations to make this were, first of all, to reduce complexity. So I like to join, for example, game jams where you have to write like a game on one weekend, which means you have to be very fast, and you should not lose much time on writing lengthy code or copy routines or so. It's often more important to just quickly write the code. It's not of utmost importance that the code is the fastest code possible. So it's more like development speed rather than optimized code. And here is some example for which a friend of mine needed copying the basic ROM into RAM on the C64. So you basically make a loop. Well, he did it in BASIC. You make a loop over the 8 kilobytes and read each byte and write it back there so it ends up in the RAM. And in LAMAlib, you can do it almost with the same level of complexity than you would do it in BASIC, but it compiles to much faster code. It's not the fastest running code that comes out of this, but it's the fastest way to type it in. So my second reason to do it was to reduce the need for labels, because those create potential mistakes. Can you spot the mistake in this code here? So this code assembles, and it's 2 parts of code copied, and then some values have been adjusted to do it first on source address and then do it on the branch target, exactly. So when copying, I forgot to adjust the branch target. The problem is the branch target exists, and also it only happens on the high byte. So this would be also a bug that would be hard to detect because it would not surface most of the time. And this is something that happens to me a lot. I don't know, probably I'm not experienced programmer enough, but it just happens. And by reducing the number of labels, you can avoid this kind of problems. And for a third reason, which is kind of connected to the first one, sometimes I have algorithms written down in BASIC or written down in C, and then I want to convert them to assembly. And in assembly, you have basically the equivalent of a goto, but you don't have equivalent of an if, of a switch, and also what you heavily use for, and what you heavily use in C would be while loops. Being able to use this kind of structured programming makes it easier to just make a mapping between your C code and the assembly code. So in bold here, you see some new commands that are supported by LAMAlib. Just very quickly, so what's the difference between macros, subroutines, and a library? The macros are something that are replaced directly in the code. So every time you use it, the full length of the macro is used. So in this case, it would be 8 byte. It's not that easy because if it would be 0-page addressing, it would be less. There is a mistake in the comment here. It's 3 plus, when address is in 0 bytes, no, it's fine. It's 3 plus 2 plus 3 byte, but it would be 2 bytes less when address is a 0-page address. But this would be an example for a macro. And then, of course, you can have subroutines, and subroutines only cost you the jump subroutine command to use them every time. So cost for additional code is 3 bytes. But when linked as an object, it is added to your program nevertheless. So if you have a library, if you have a subroutine which you don't use, it takes up space if you link it to your program. In addition, it gives you a small timing overhead. Small, depends on your requirements. But it also gives you some timing overhead because you have to do the jump subroutine and the RTS. In contrast, you can also do the same stuff via a library function. And this also works with subroutines. And in this case, it is only linked to your program if there is a reference to it. And the CL65, so the linker of the CC65 environment, supports libraries so that you can automatically avoid including stuff that you actually don't call and that you don't need. So unused functions don't cause an overhead. And this was a great way to introduce a lot of functions to make like a big catalog of useful functions. And on the other hand, ensure that you don't add any overhead to your program in case you don't need them or because you don't call them. So we have a big library, but a small overhead or no overhead to your program if you don't use any functions. We use LAMAlib, so it's available on the GitHub page, and there is an installation script that comes with it. And the installation script copies some files into the include and library directory of CC65 if you find CC65 installed on your system. And if this succeeds, then you only have to include, add a line include lamalib.inc at the beginning of your code. And when linking, you need to add this -lib lamalib.lib in your linking command, which adds the functions that you refer to. Doesn't add any functions if you didn't refer to them. If you only use macros, you can even omit the adding the lib, but it doesn't come at any cost, so it doesn't matter if you add it anyway. It also comes with a script as, which just means assemble, doesn't mean anything bad, which adds also a basic stub to your program if you don't specify a target address. So you can write a short assembly program with LAMAlib as it, and then you get something that is runnable right away. A very short overview on the macros. So it first contains something which you probably have seen before with other macro libraries or macro packs, 16-bit macros, just things that do more or less the same that the standard 6542 commands can do, but for 16-bit. In LAMAlib, there is, since in CC65, the registers A and X are often used as a 16-bit register. LAMAlib does the same. So it's using AX. And so for each, or for almost all commands that operate on the accumulator, there is a version that is using AX. So there is, instead of LDA, there is LDAX, and you can load a 16-bit value into A and X. You can load from an address, you can add to AX, you can roll, ROR, EOR, compare, store, just the usual stuff. There are also some macros that are operating on memory. They have the suffix 16, so decrement 16, increment 16. And as a courtesy to guys who like BASIC, like me, I even added a poke and the poke word macro, which just loads the value into accumulator and stores it into the address. But it just saves me some lines using poke instead of LDA, SDA. Then there are some convenient macros and subroutines for outputting stuff. There is a print AX, print a string, print immediate. And there is a meta macro to this print, which just tries to detect what kind of arguments you give it and prints this to the screen. So it works almost as convenient as the print command in BASIC. There are stuff for clear screen, setting cursor position, new line. This is nothing magic, but it's convenient because it saves you the time looking up how to set the cursor position on these machines. There are commands for delaying some given milliseconds, multiplication and division. a function for identifying the SID. This, of course, is a C64 and C128 specific function. Same with the set raster IRQ function. There is one that's helping you disabling the NMI with a trick. There is a memcopy, memset. It's just a collection of stuff that might be quite useful. And I think it's good that it's there because at least when I need to quickly write some code, I use this stuff a lot instead of coding it anew or looking where I have done it before and copying from there. What's my opinion, the most interesting thing are the macros for structured programming. So there is a macro for next structure. So you can define a register that should go from a starting value to an end value with a given step. Step could go upwards or downwards. And it's closed with a next macro, and everything between for and next is then repeated with the register in between being adjusted, like in the basic for next function. There is support for doing if, else, and ending the if with an end if. There are loops, which are basically defined with do loop, and with until and while conditions, you can define how to exit the loop at some point. There's also support for break and continue, as you then probably if you do some C programming. There's a switch case. Not that known from other programming languages because you don't need it there, but in assembler you need it a lot. There is a function to store one of your registers and to restore it later. And what it does is to produce the self-modifying code to store the value of your register at the store point so that in restore it's loaded again. It can be also done, at least for the accumulator, it can be also done with pushing and pulling with the stack. The advantage of the store restore is that it is a bit faster and you don't have to take care that you hit the restore in any case. So with store restore, you can just jump out if you feel like it, and you don't have to worry that there is probably some unpulled accumulator value still on the stack. So it's a little bit more convenient. And of course, with X and Y, you can do it without using the accumulator. While if you do the stack version, you would have to transfer X to the accumulator, then putting it to the stack, then getting it back again, moving back to X, which basically clutters up your accumulator. For all these functions, I spent a lot of time into making them recursive. This was quite some effort because I had to come up with a clever way to create levels that depend on the recursion level. And I also could have used a scope and scope construction. But if I do this, then a user could not refer to labels inside loops anymore, or at least not easily with the standard naming scheme. And I didn't want to take this away from the user. So I came up with a solution that does not use scopes and just creates a lot of different labels. It's possible to have up to 9 different recursion levels, and there was still don't have to use scope. So this is something that went into there. So the most complex macro in this whole LAMAlib is actually the next macro. The next macro is several pages long, and it has to take care of so many conditions and so many possibilities that have to be taken into account. It's a bit crazy, but from a user's perspective, it's easy. You just write for next, and it's doing what you want, hopefully. For the if condition, I didn't go into providing passing of expressions. but rather made them operate on the flags of the processor. So have if or also until or while trigger on equal, not equal, minus, plus, on the carry being cleared, on the carry being set, on the overflow flag being cleared or set. And you can also use less than, greater, equal as conditions, but they are just based on the carry ones. Yeah, and that's the stuff for the structured programming. So now probably there is a question: how much overhead do I have to accept when using this kind of stuff? And I tried to bring in as many optimizations for loops as were possible. And for example, cases where a loop goes down to a 0 omits a compare in the loop instruction, a compare instruction in the loop, because you can just do it with checking on the equal sign after a decrement of the loop variable. If the loop goes down to 1, you can do it after this and can do it with branch no equal. So stuff like this has been implemented. And you see here 2 examples of defining loops. So there is a for loop that is clearing the SID registers, and it's using the X register, which goes down from the last SID register to 0, and it stores and then uses X as the index variable to store into D400. This is where the SID is mapped on the C64. And this generates the following code. And probably this is what an experienced programmer also would have written for exactly this purpose. So it's not doing anything very odd here or adding a lot of overhead here. The second example here is using a down to 1, and now you have to adjust the offset a little bit to make it doing the same stuff. But you see here that the loop that is generated, the code that is generated also is the same size. It's also quite efficient, and it has changed the condition on which the loop closes. So the first example uses a branch of plus, and the second one is branch not equal. So if it knows the end value of the variable, and it can use this in order to make a very efficient comparison, it does it. So if you compile this, for example, if you compare this, for example, to compiled C code, in this case, we would have to use, or at least I used the 16-bit loop to have a fair comparison. So I rewrote the clear SID registers stuff in LAMAlib with a 16-bit loop. So I had the AX register running from D400 to D41B. And then I'm using my poke AX, 0. I think this is easy to read. And the code that is generated from this is shown on the left side. If you compare this with a C program, where you also, I just named the variable here, AX. Of course, AX here is not the registers anymore, but this is a variable. And I also let it go over the same range. And I also used the poke macro here. The poke macro is explained above. And this is what you get here. And please note that we have like here 2 columns of code. So the generated code here is 2.5 times longer. So with LAMAlib, despite that there is support for structured programming, it is not a compiler. So it's not that we left the domain of assembler coding. It's still assembly coding, but it just became a little bit more convenient. But we're still efficient, we're still fast. Well, so to just quickly come up with my takeaway message. So if you already use CC64 and assembler CA64, then LAMAlib might be a nice add-on for you. And new programmers gain a reduced complexity, and experienced programmers gain the reduced complexity. It's something which it's always of some value. And the library is in continuous development, so new functions are to be added. If you have something where you say, "Ah, this might be a nice add-on," and it's not there at the moment, please drop me a mail or write an issue on the GitHub page. If it's doable with reasonable effort, I'm very happy to do so. Currently, my next to-dos are for supporting high-res graphics. And also, there are many hardware accessing macros that are designed for C64. So I'm also planning to add support for the other machines, and especially for C128. There is a lot of large world to discover, especially when we look at the VDC chip. And this is currently missing, which is quite a big chapter to address, but this is definitely already on my to-do list. So you can get the newest version of it on the GitHub page. So Demesos is my user there. So if you want to contact me, you can do it via this user on LAMAlib. And yeah, that leaves me to thank you very much for the invitation to being able to present LAMAlib here and for attending my talk.
Thank you, Wilfried. Thanks a lot. I see that there's a couple of questions. One from on Andre has already been answered. I see he was asking how large was the code created by the next macro, but then he said, okay, you answered the question. And then there's a question from Michal. If it's possible to nest, store, and restore. So he gives the example there to do store A.
Yes, it's possible.
Yeah. Okay.
Yes.
Good to know. Michal, do you have any follow-up question on that? Or?
No, I just want to know, because you said that you're not using the stack. So I just wanted to know if you just store the value in some specific place in memory, and can I use several store instructions and then it will restore everything properly? So if you're saying yes, then I'm very happy about that. That's all I wanted to know.
Yeah, I'm not using the stack, but I'm using self-modifying code. So the code example that you posted in the chat would generate code where the first store would store it to a label that is dynamically generated. The second store would store it to another label that is more deeply nested. The first restore would then have the label of the second store, as you suggested in your example, and the last restore then would fit to the first value.
Okay, so basically it depends on the order of store and restore instructions in the code.
Yes.
So I cannot jump between restores. I need to execute all the restores as they are written in the code.
No, actually, you could, for example, in the middle of your example, you wrote more stuff.
Yeah.
You could jump over the restore there and go to the last restore immediately, and it would give you the value from the first store.
Okay, yeah. Okay, that's cool then. That's very cool.
Perfect. I don't see more questions. Maybe I have a last one while I will then stop the recording. Maybe last one, because now, of course, you have posted this on your GitHub account. But do you know of any project that is making use of your LAMAlib? Any, I don't know, any known project or program where it has been used apart from, I suppose, your own code?
Of course, I have used it in my projects, but there is a colleague Pararam from the 7th division who is now using it also in his projects.
Okay, Okay.
He was also the first one to write an issue there.
Yeah, but that's why you need actually users, because then people can report if there is something not working as expected or something. Okay, I would say thanks a lot, Wilfried. I will now stop the recording. If there are more questions, then of course they can still be asked in the chat, and you can answer them from there. I stopped recording, and then we can welcome. I think it's you, Brian. Yes, it should be Brian, who's already in since the beginning of the meeting. Feel free to start sharing your screen. The floor is yours, Brian.
All right. Let me get to share the screen. There we go. So,
Yes,
are you seeing my screen now?
Yes, we can see your screen.
Okay.
So assuming this is the AOZ editor, right? Perfect, Studio.
Okay, just a moment here. Okay, well, hey, my name is Brian Flanagan. I've been an Amiga user since the late 80s. I was part of the Gateway Amiga Club that's here in the St. Louis, Missouri area in the US of A. I was a leader of the AMOS Basic Programming SIG at Gateway Amiga Club. I still own several Amiga systems, 500, 2000, 3000, 1200. I actually used the 3000 and 1200 recently, so I do actually still use them. In any case, I love this product. I've always loved AMOS Pro, and I love AOZ.Studio. I think with the current upsurge they've had in the interest in retro computing, that AOZ.Studio is coming to the market just at the right time. But it's not just a retro platform. AOZ is much more than that, because it's a highly enhanced version of AMOS Pro with superior capabilities and features. I first heard about this back in June of 2019 because Francois Linné was writing AMOS.2. I heard about that and it's like, I got excited because I've always loved it. But he wasn't updating the Amiga version, rather he was creating a new version of the language that would run on multiple platforms, modern platforms. So running Windows, Mac OS, Linux, Android, iOS, basically any modern platform that will support modern web browsers and JavaScript. And this was kind of a new concept because AOZ, it's not an interpreter, but it's not a compiler either. It's rather a transpiler. And what it does is it takes your AMOS basic code and it converts it to an optimized JavaScript. And then you can run that on any platform that supports modern JavaScript code. Uses the newer technology, Node.js, JSON, all the various JavaScript APIs can be included in there. So that makes it pretty interesting. Now, in case you need to get a hold of me after this, you can go to our Facebook page. You can see the address up there. And you can also go to our Discord page. We got a lot of good people there who can help you with your questions. I'm usually there. And if you want to contact me personally, there's my email address, but please don't spam me. So everybody who's hearing okay, I hope, right? Hello?
Yes, we are here. We can
okay, I'm just making sure.
Yeah.
Anyway, I became when I saw that in June 2019, I started. I was a beta tester for the product, and I was helping them find bugs. And later on, about a year later, they actually incorporated the company. So the AMOS.2 project became AOZ.Studio. That's the name of the company and the name of the product. And I was brought on as a part-time developer. I still do a lot of beta testing, fix bugs, and I've even added a few commands to the language and updated the docs. I did a lot of stuff there. But enough about me. I'm sure you want to know about AOZ.Studio and how you can use it to bring your AMOS Pro creations to modern systems. And even with some careful planning, you could use AOZ.Studio as a RAD platform, as rapid application development, for prototyping your AMOS Pro creations. So let me give you a warning on this, though. I'll let you know, AOZ.Studio, it's not an Amiga emulator, and it is not 100% compatible, but we like to call it AMOS friendly, meaning that most of the important AMOS Pro commands will work in AOZ.Studio, and if you're careful to avoid any commands which aren't supported, and you're likewise careful not to include any of the new commands, then you could take this code and port it back to the Amiga. So I was told that there would probably be some people here who are wanting to do that, so just thought you want to know. In any case, let's see. Oh yeah, and just keep in mind that it's not really designed to be a development platform for the Amiga, but if you're careful, you can use it that way. So in any case, I just want to start and give you an overview of AOZ.Studio, how it works, and I'm going to go to live too, so you can see it in action. Just a moment here. Get this presentation out of the way. And what you see here is AOZ.Studio. When you first open up AOZ.Studio, what you're going to see on the left there is something like that. You'll see my AOZ applications, manuals. I'll just tell you what all these are. My applications is pretty obvious. That's where you store your programs. Manuals, these are instruction manuals. The AOZ store, we have there some demos, games, tutorials, utilities. In the future, we'll have other things there. And I didn't say so, but just so you know, this is a beta product. It's not 100% done yet. So if anything weird comes up while I'm running it here, that's why. Our actual release date, we're planning on putting this out in September for the real version. And if you want to get involved and look at the beta, you can go to the AOZ.Studio website and you can download it there. In any case, let me just kind of whet your appetite. I will bring up some of the things that people have done with this already. How about we start with, let's go with the demos. And where is that thing? Oh, graphic demo. This one, I love this thing. And the reason I'm bringing this one up first is this is it uses mostly the normal AMOS Pro commands. I'm told there's not much in here that shouldn't run on there, so you should be able to take this and run a lot of this on your Amiga. What you would have to do, though, you'll notice here on the color statement, you have 24-bit color there, because this one was designed in the standard AOZ mode. In standard AOZ mode, it runs with a display, a 1920 by 1080 display, 24-bit color, and has all of the features available to the language. Now, if you want to run it in Amiga mode, you actually have to start out, say if you're going to create a new app, you'd start out here and you click on this icon that says Amiga, and then it will configure the system so you can do your Amiga programs. So, but back to the code here, let me just show you what it looks like. And you see, yep, we're transpiling live there. And you see a pretty picture. Not that impressive yet, but I tell you, right now, let's speed it up a little bit. And let's add some circles on the end here. We got those. And well, let's see, how about add some polylines? So it's drawing lines in between all of these. And you notice up there, that's 500 bobs that are displaying pretty fast now. We got 29 frames per second. If you see it, see in the upper left corner there, 29, 28. So pretty close. And that's one of the nice things about it. It's very fast, very efficient. I'll just go through a few of these other presets just so you can get an idea of other things you might be able to run on the demo here. Lots of cool stuff. So let's continue on though. And let's try one from the original AMOS guy. This is one from Francis. He created this back when it was still called AMOS.2, and it also uses your standard AMOS commands. And let me go in here. You see, can't quite tell just yet, but that is a whole string of AMOS of those Amiga balls. And I'm just going to add a few more things in here. And let's speed it up a little bit. And as you can see here, we are animating now 1,790 bobs, and it is running pretty quick. Pretty cool stuff. So let's try another one here. Okay, let's try this. This is a program that was actually ported from the Amiga. This was one written by Dave Baldwin. He's the one who also did that graphic demo. And this is a very cool Pac-Man type game. And again, there's not a whole lot in here that won't run on the original Amiga. So if you wanted to, I haven't tried it yet, but if you wanted to, theoretically, you could port it back and run it on the Amiga. Now, the only thing, that was one thing, those screens that are all twisting around there, that was the one thing he said this would not easily port. But if you see here, this is running pretty much like his original Amiga program. There is a little caveat here in that right now we do have a bug in AMOL commands. If you're familiar with AMOS, you know about AMOL. So right now, not all of the AMOL is working. So it'd be nicer if you saw it all. But I'm trying to go through these quick because I know we have limited time. I'm going to try one more demo here, and this one is called Sibnet, or Sibnet. Phil Bell wrote this one, again with a pretty early version of AOZ.Studio, and it is a pretty cool horizontal scroller. You'll see here in a second. By the way, we do support on the newer platforms, we support any kind of USB joysticks. You can use the mouse, of course. or you could use the keyboard. All three will work on here. So right now I'm using the keyboard. Mouse is not supported on here. However, the joystick is. Which now I'm using the joystick. Phil did a great job on this game. So,
And I think there was a conflict with the sound of the game and your microphone. There was okay.
I'm
Maybe
sorry,
not.
what did you say?
I think there was a kind of conflict with the audio of the game and
Okay.
and your microphone. So
Yeah,
the last,
I think I got the speaker turned up a little loud here. In any case, yeah, Phil Bell created that game, and it's pretty cool stuff. And these were all created with AOZ.Studio, and if you look at the code, it's like your standard AMOS code for the most part. There are a few things that are different. One thing here, you see these curly braces here. With the curly braces, you can actually embed JavaScript code inside your app directly. So this is just setting the title bar on the page. But the rest of the commands here, degree, global, the variables, dimensions, whatever, it's standard AMOS commands. Now there are a lot newer commands, which are pretty cool. And we'll get into that if I have time. I want to make sure I leave time for some questions here. Let me go back and let's see if I'm missing anything here. Go back here. Make sure I'm not skipping anything. So
maybe while you go through it, I can already ask maybe a question. Is this editor then that can you sync it with an online repository, or can you work can you also work collaboratively with other, let's say, friends or a teammate?
Well, we don't have AOZ.Studio working online right now. I mean, you could collaborate. You can export the code to an AOZip file. It's just a variation on a zip file, and then you can take that file. Somebody can import it into their system, and they could make edits to the code. But no, there's not any way at the moment for a collaborative process. Oh, that's a good idea. We'll have to add that to the list. That answer the question?
Yes, absolutely. Yes, thank you.
Okay. And now, and this is just so you know, AOZ.Studio, it's like it is right now, it's for free. It's but this is not public domain. There is a free version, and with the free version, you can see up here that you will have advertising in your programs, and you don't get any support if you're using the free version. Now, if you're willing to pay for it, we have a 2-year license for 89 euros, which is quite reasonable compared to other similar products out there, or a monthly license of 9. With the paid license, you can distribute your programs, no royalties, and you get the support. And just so you know, we are working with educational groups, and if you are affiliated with any educational group, contact us, and there are special arrangements we can make for that. Let me go back. See if I don't need to close that. I just want to make sure I didn't miss anything here. Okay. Looks like that's about it. Now, what other questions might you have? We got the one question there. I know there are certain things in the AOS that are not working, and that's primarily the commands that are specific to Amiga hardware, or to Amiga software, like the exec calls, graphics calls, to the graphics library, like you would with an assembler program. Oh, one thing I forgot to mention. You might want to know how extensions work. Now, AMOS Pro, you have extensions, but for the most part, the extensions out there that are assembly language, and those are not going to port over. But the nice thing is you do have the ability to create extensions in AOZ.Studio as well, and it's actually fairly easy to do so. And you can also create your own functions. So I just want to leave the floor open for some questions. Anybody have anything right now?
I don't see anything in the chat. I don't know if there are anyone with questions for Brian. Otherwise, also looking at the time, I see we are completely out of schedule.
Yeah, I was trying to run through it quick because I knew we were behind the schedule here.
Well, but we are also between us, so that's not an issue. But I would say then, if no more questions, then I would invite our last.
If we do have time, I would like to show you a little taste of some of the new things that you can do. I told you there are many enhanced commands. There's a command called actor, you see up here, and it's a very powerful command. This is actually a very simple form of it you see here, and I'll just run this for it. Right now, we're creating an actor, which is like a bob. Putting it XY 600, 600, and this is the name of the file that it's getting it from. And I'm telling it, I want to control this with the joystick. And then the other one, I'm going to control with the mouse. So I'll just run this so you can see how it works. And the interesting thing about it is these are actually some built-in objects. Lucy and Magic are two of our mascots here. This is Lucy, the little wizard there. And the flying eyeball there, that's Magic. And as you can see, the collisions I have set up to call the boom command, which I'm sure you're familiar with if you used AMOS before. But just look at how few lines of code we had to use to do that. The hotspot command here, I used the old style of doing that. You can actually include that in the actor command as well. But the interesting thing is I didn't have to reference any of these. It'll automatically copy those over into your code, these the magic.ping, lucy.ping. I didn't mention it, but yes, it does support IFF graphics. So you can load your old IFF. At this time, it doesn't yet support IFF anim. Hopefully we'll have that working eventually. But in any case, there's just a little taste of some of the new commands that you have available, or one of them. And just one other thing here. There's also a lot to that actor command. I told you this is actually a very simple form of it. If I look up in the help here on actor, you'll see here there are many parameters that you can add here. You could almost create a whole game with one line. Because it's, and we actually have had some people who created games in less than 100 lines easy using the actor command. So I guess I'm out of time. I just wanted to get that in so you get a little bit of taste for the new stuff. So.
Yeah, looks really good. I would say thanks a lot, Brian. I don't see any other questions in the chat, but if they come, maybe you know, people can put them in the chat and you can still answer them from there. I would say thanks a lot. Maybe can you just show again what is the link so that people can so there is a free version.
You just want to see the contact info again here?
Yes, maybe just you know, to have the link.
Look here. Yes, it's just our Facebook page, groups/AOZ.Studio. And also, I didn't even put it on this page, but the AOZ.Studio website is just called AOZ.Studio. It's not .com, it's .studio. So,
perfect. Excellent. Thanks a lot, Ryan. I will stop recording now, and I will welcome then our last speakers from today. It's Adrian and Graham for ThePast.
Okay.
You should probably stop sharing. Yes, thank you. If you can then stop sharing, and then I don't know who from the speakers.
All right, just
Adrian
here. I will
will take
that for you here.
Hello, can you hear me? Am I coming through okay? Yeah,
yes,
good.
Yes, I can hear you.
All right, okay.
Me also.
Yeah,
okay, should be released now.
Perfect, thanks.
All right. Well, hello all.
Hello.
Yeah, so we're Zappedto. I'm just going to share this. So we're going to keep, obviously we're running late, so we're going to keep our part nice and snappy and nice and quick. We've all got Saturday evenings to go to, and the football's on. So let's get on with it. Can we all see that? Is that okay?
I can see your screen, yes.
Yeah, cool. So that's us. We're Zappedto. For those who don't know who we are a C64 podcast. We're we're about 4 months old now, so we've been running since beginning of February. We've got about 21 episodes out. What are we? I had always wanted to do a podcast about something, and so it seemed logical with both myself and Graham's love of Commodore 64 games from back in the 80s. We should probably do something around that, but it was tricky to find the right angle until I hit on the idea of using Zappedto magazine as a guide for to what games to look at. So each episode, over 2 episodes, we look at all the games that were reviewed in every issue of Zappedto, the seminal Commodore 64 magazine. So we are working from issue 1 onwards. We have done, where are we up to now? We're up to January 1986. So the first half of January 1986 has come out, as hopefully you can see there. And we are staying true to our course. So when I came up with that idea, I pitched that to Graham, and then Graham did his usual stuff of making it all shiny and good. So Graham, you tell us what you did.
So AD pitched me the idea. And like AD, I always had a bit of a penchant for doing a podcast. I've been got a long history with retro and with retro stuff and with the C64 in particular. And like AD, we're school friends. We were school friends over 30 years ago. We've never lost touch with that. And so we wanted to make sure. So from a technical, we want to make sure it was at the right sort of tone and the right thing. So from a technical point of view, we needed to figure out a way during lockdown, because the UK has been like locked down. I mean, we all have, but we've been locked down for what seems like forever now. So we needed to find a way to be able to record this with a good fidelity, and we wanted good production values. I brought some ideas to that. So I wanted to use some good quality software. I wanted to make sure that we recorded it, because obviously Adrian has to record the audio at his end. I have to record the audio at my end. I then have to get the 2 audio streams, merge them together, which means that to get the synchronization at the beginning of every recording, I delete this, but AD has to do a loud beep.
I do.
For my shame. So he has to emit a loud squeak, which I can use to synchronize the audio at this end. And once we do that, then it's a matter of just going through the audio, cleaning the audio up, making sure the balance is right. I then had to get a load of interstitial recordings because my plan for the podcast was that when we reviewed the games, in between each game, I wanted a little bit of C64 music. We all know that the C64 has an incredibly good sound chip, right? So I wanted to sort of utilize that, where possible, exploit it as much as possible. So our background music for the podcast was always going to be C64 audio from games. And I'll talk about why that was quite interesting in a minute. And also then I wanted to make sure that whenever we changed from between games, we had a little bit of either the kind of music that you get in games that would be when you go from one level to the next, or if you died, or if you started the game. A lot of those C64 games from back then have that music. It's something you don't get anymore. But that kind of start the game, level game, end of game, mobile games have it a little bit maybe. But I wanted to use that for sort of in between the recordings. And then we discussed we just didn't want it to be just about me and AD talking about C64 games. We felt there needed to be a bit of a break. AD came up with a great idea of let's introduce some of the what was going on in the 80s at that time in the magazine. We'd played with the format. We recorded an episode, right? And AD will remember that we recorded episode 0, which was like a technical test. Everything that could have gone wrong in the episode did. So my microphone, I had a very expensive microphone that broke pretty much immediately. The Zoom that we were recording on went wrong. I think I deleted one of the audio recordings by accident. Adrian was on a headset with a microphone close to his mouth. So he had the worst plosives in the known universe. I was on a microphone that was too loud. So it was we just had to get the balance right. And we debated it, and we ended up putting episode 0 out. So you can actually go onto the website.
Here it is. Look, there it is.
So there's our pilot episode. So that was the least produced thing we ever did, because obviously we got a bit better at the production and we decided on the format. And over time, we decided that we were going to split the games up into sort of sections. We originally put all the good games, I think, last. Did we put the good games first, AD, or the bad games last?
It was good games first. Yeah.
and then we realized that if we did that, by the time people got to the end of the podcast, they were kind of doomed out because we've just been saying how bad these games were. So we figured we'd mix it up a bit. And then obviously we put in the music from that particular month around the 80s, the chart music from around what was going on. We originally had a little bit of news, but we just quickly found that most of the news in the 80s was really bleak and really sort of mostly about nuclear war. So we just we just knocked that on the head, and we just focused on the music, on the movies that came out and the films. And we put a bit of a section into that. We originally split the podcast over 2 recordings because we record it in one sitting, but it's actually about 4 hours of recording. And so we thought, actually, do you know what? That's a long time. Let's split that into 2. And then we decided we were just going to make it episodic and just split it into more of a sequential part to make it make sense for people, which we did. And gradually over the time, we've managed to sort of get the format now. So we know that we're going to review the magazines. We split them into chunks. We have the music in the first episode. We do the second lot of games in the second episode and put the films and TV. And of course, my little addition, such as it was that I said to AD that there was a lot of crappy, and for want of a better description, rubbish adverts that appeared, games adverts that appeared back in the early days of the C64, not just in C64, but in games magazines in general. They didn't quite know how to advertise games. And so they went through a phase where the advertising for the games in magazines was really poor. And we decided to sort of take a focused look at that and just make that kind of the fun end of podcast thing that we do each time. So we look at what we call the crapverts, which are just the adverts, as you can see, where visually don't make a lot of sense. And we thought that'd be a fun addition. So we've come over time to sort of get the format right, the technical aspects of right. I've upgraded my microphone, thank God. AD's now got a new microphone as well. So he's not on his headset, which means I don't have to filter his plosives for at least 2 hours of my life. It's been a journey, but do you know what? Gradually over time, we've got a nice following. People kind of like what we do. It's great to get on things like this so we can talk about it as well, because it's great to just meet like-minded people and just be able to chat. And there's been some amazing discussions in this video as well, especially with some of the AMOS stuff that I was seeing, because I'm an old Amiga programmer. I'm an old C64 programmer. I go way back. So the 6502 stuff I was seeing, and then the old assembler stuff was really lighting my fires a little bit. Something I really do need to get back to given time. But at the same time, we've come a long way with that, I think, AD, right?
We have, yeah. And we've covered a lot. I mean, obviously from your side of things, you do a lot of the technical stuff, but it's been a bit of a journey of it's discovery, because we're playing loads of games. The thing is, we're playing loads of games that I've never heard of. And so sometimes that is can be hit and miss. Sometimes you find a hidden gem, but a lot of the time, we're playing a lot of games, and you can see here just from this. If you go to the website is zappedto.thepast.com. You can see all the games we've covered, and I think we're pushing well over 200 now that we've covered, and we're only 21 episodes in.
We play each one of those games as well, right?
We do. We make it a point of that we have to play every single game for as long as, sometimes for as long as we can stomach, because they're not. There are highs and lows, as was noted in the reviews back then. And yeah, we're getting better all the time, and we like to think we're gonna continue with this. This is something we have committed to. So I think there's about, I don't know how, there's about 90 odd issues. I think 80, 90 odd issues of Zap. So I think it changes to Commodore format one or Commodore something later on. So we don't know how far along the line we're going to go, but I certainly have the plan that we're going to go up to 1990, probably 1990 at the least. So if you are looking for, while you're doing all your amazing technical stuff, if you're looking for something to listen to for a bit of entertainment about the Commodore 64, then hey, Zap to the past. That's what we are.
So it's good background. It's good to have on in the background.
Yeah.
And also, to be fair, I mean, like I say, I actually bought a C64 Maxi. AD's got it. We couldn't. My plan is to get an actual C64 at some point, a real old. Go to eBay, buy one, make sure it works, because I know there's loads that don't. I did have one, and I stupidly gave it away. But to actually get a C64 and play these on the real hardware, at the moment I've got a C64 Maxi. AD's got a C64 Mini. I have the clickiest micro switch joystick in the world. Yeah, if I use that joystick, I'm pretty sure everyone on this recording will be able to hear it because it clicks so loudly. So I've got to figure out and get a better joystick. But you know what? It's the best I can do at the moment to sort of play those on that emulation and play that. I'm getting an equivalent experience from it. And so at the very least, it's that. And we do play them all, good or bad. And we say that's the motto, kind of become the motto of the show. We play them so you don't have to, because as much as there's some amazing early games, and there are, and it's really great to come across some of those titles again. Because I stepped away from gaming for quite some time. I came back to it on AD's recommendation much later after AD, but I came back to it, and it's great to come back to some of these early games. I played all of these in my youth. It's not like I didn't. I was a member of a big demo group in the UK. We coded a lot of demos, but I was one of the chief swappers and coders. And so I ended up with lots and lots of legitimately acquired software on disk, to say the least, but I ended up with a lot of it. And so all of these games we've played at certain points, but some of them always stand out. So your Paradroids and your Byron Wiggins that we've waxed lyrical about on the podcast, those and as you see, the Frankies and the Summer Games too. Those games are genuinely brilliant games, even for back then. So it's great to revisit them and play them again and get that feeling for them. But for every Summer Games 2, you've got a Dickie's Diamonds or a Vegan Attack or some of those. So we have to tread that delicate balance. I find it's a great thing to be able to do. And if you want to follow the podcast and follow along, you can follow us on all the usual places. The great thing to do, though, is not just follow us, but play the games that we play. Experience them for yourselves, because as much as there's some real rubbish in there, there's some absolute gems as well. And when you find one, like I did when we went back and I replayed Way the Exploding Fist, which I hadn't done for quite a long time, it was just brilliant. You forget how great these games are. Even at the time, they were just really good. And the great thing is, sometimes in your mind, I don't know if Ada, you feel this, but I know these games coming up we haven't got to yet, and I know how good they are. So I know we're going to get International Karate. I know we're going to get things like that. I know it's coming soon. I get excited for those.
Yeah, there's a slew of games that we're looking at over the next few recordings that I'm quite looking forward to. But alongside those, yeah, we know those big games, like I said, the Exploding Fist, your Drop Zones, your Frankies, your Summer Games too. But the good thing about this, what I've enjoyed doing, is a sort of, it's kind of becoming like some kind of oral record of all the games, everything, because there's a lot of talk around. You find there's a lot of talk around a lot of the games. Singular games, you get those kind of games that are always talked about. But what I'm finding in doing this is that it's kind of opening up conversation around, who talks about Tour de France? or Who Talks About Dickie's Diamonds, or Ghost Chase, or Migali Ace, or Out on a Limb. These kind of games, you know, whether they should be spoken about is open to debate, but it's good to give these kind of games a relook, because yeah, maybe we played some of them, and some of them I have no memory of. So, but that's kind of what I'm enjoying from this, is going back and playing through all these different kind of experiences and just seeing what at times what the Commodore 64 was capable of. And also, just from a personal point of view, I teach game design, and one of the modules I get my students to do is to actually remake an old game. And this is proving an absolute goldmine of stuff to get them to do, because it's like, you know, here's a game, remake this in 3D. That's what you can do. And they do, they really enjoy it. So that's, you know, it's part and parcel of why doing this has loads of benefits for us. But yeah, I don't think I've got much more to say. There you go. That's us. It's up to the past. Unless you've got anything, Graham.
No. And was the only thing I was going to add just to that was that it's amazing when you play these games that you see the genesis in these games for the games that are coming out now. All of those great big games, all of the multi-million-dollar super franchise games. At certain points, we've noted that there's certain elements of these early C64 games, and even the games that because it's often if they're multi-platform, that the early acorns in these games that get planted, and then they've grown through all those designers and developers who've grown up with these machines and that code, even through the Amiga and the Sega and all the rest of it. Some of those core themes remain. The shooter on the C64 is still a shooter now, whether it's on the Xbox or whether it's on the PlayStation 5 or whatever. Some of the fundamental game mechanics in those don't change, and I find that quite fascinating. But it's been an amazing experience that we're doing, and I can't wait to play more of the games. And a great chance for us to just to be able to speak to some like-minded people, which is really, really cool.
Yeah. And if you do want to find us, or, you know, we're just to give us where you can get us, we're at Zappedto on Twitter, Zappedto on Facebook. We've got the group and a page, and Zappedto on Instagram. And obviously there's just anywhere you search for Zappedto, you're gonna hit us.
You'll find us.
You'll find us there. Yeah.
Excellent.
So there you go.
Excellent. Thanks a lot. I think it's really a challenge. To me, it sounds really like a challenge to play all these games, because there were of course a lot of good games, but there was a lot of trash actually.
Well, like I said, so far we've been recording. When did we start recording? Was it November?
Yeah.
So we're in June with over 200 games we've played in that period of time. So yeah, it's and God knows how. I think, you know, we'll be well over 1,000 by the time this is finished. But you know, we're going to be here for the next 2 or 3 years anyway. So, you know, count on us for your Monday morning. It will come out on a Monday morning, by the way, as well. So if you anywhere you get your podcast, Spotify, Apple, any kind of download stuff, we're there. So if you want to, you know, a bit of background listening for your week about Commodore 64 games, hey, there you go.
Yeah. Now I'm curious. I really want to listen to the pilot. You know, the number 0. That's the first one I want to.
I think that's actually got the most games we ever reviewed for a single episode in there.
Yeah, part 2. There's all those. Yeah, because what we did was just to sort of give it some rationale behind episode 0, because Zapp64 started in May 1985. We were well aware the Commodore 64 was 3 years old by that point, or approaching 3 years old. So we had a whole 1982, 83, 84 to sort of go back and look at, but we had no guide to that. So what we did is, and we just picked games that we kind of knew, had played, had a reputation from those years. I just went to Lemon 64 and just went through their back catalogue, put 1983 in the search, and went and had a look. And we picked a chunk, and we made a big list, and we highlighted the ones we wanted to play, and you know, that's the ones we've got there. So there's tons we didn't pick, and we didn't look at. So you might look at it and go, oh, fine, you didn't play Bruce Lee, and we've had that comment from people, or you didn't play Fort Apocalypse. It's like, well, we can't play everything. We try to, but especially from a 3-year period in the first time we did it. But yeah, that was the rationale behind that. So once we got to episode 1, we had a clear guide to the games we wanted to look at. But even then, in issue 1 of Zapp, we couldn't fit it all in. There's about 25 games. I think we did 19 of them. But we are getting to a point now where we're playing everything they review. We don't do adventures and we don't do strategy. That's our motto. Because we're not adventure people.
And you don't want to spend 3 hours.
Yeah, that's exactly it. Yeah, that's exactly right.
fully understand. So thanks a lot. So Zappedto.com, I guess, and then you have mentioned as well your Facebook. You're on Facebook and on Twitter.
Yeah.
I'm just looking at the chat. I don't really expect questions here. No, there are none. But of course, if they come, you can still answer them in the chat. I will stop the recording now. We have reached the end of the agenda for today. I want, before we close, maybe quick stats from the Commodore Users Europe, at least on the Facebook page. Our biggest community for the moment is UK, top 1. Top 2 non-European location, that's the US actually. So most of our followers are number 1 UK, number 2 then it's US, number 3 is Poland, number 4 is Italy. And then we have more or less a cluster of Germany, Spain, and France, and then comes Belgium, and then it's more small numbers, I would say. I want to thanks again all the speakers and of course the attendees. Again, continuing with the stats. So today you see that we were, I think, 18 maximum in the Zoom call. There were at some point I saw about 15 people attending from the Facebook streaming. But just know that, for example, the March meeting, the video is still available and can be played on Facebook. There it has reached more than 2,000 views. And also the YouTube channel that we created only 2-3 weeks ago, and where we post each individual talk of the conference, let's say, of the event. There we have already reached like 500 views in total. So we will post again these the talks for today, from today also there, so that people can find them simply and replay those. The next meeting then we will have is on the 18th of September, right? So after the summer holiday. So if you have projects to bring for the meeting, don't hesitate. You get back to us via either the mailbox or the Facebook page or the contribute page that is on the website. Once again, thanks a lot. I think we're going to close. If there is no last question or comments from anybody attending. I don't think so. Perfect. So thank you very much, everybody. Have a good end of day, and yeah, I guess we hear or we speak soon. Bye bye.
Thank you, everybody.